Yes, my hw3 program, it reads a CV instruction from input text, line by line, figures out the instruction format, RIS, SB, U, or UJ, and prints that format along with the immediate value or label. At the top of the data section, I declare a 256-byte buffer for the current line, a 34-byte buffer for the extracted mnemonic, and a set of output strings, one per format, that get printed once a line is classified. Below that is the real heart of the design. Every mnemonic I support, written as a new terminated string and grouped by which instruction format it belongs to. R-type ops like add and sub, I-type loads like load, other I-type ops like add, S-type stores, SB-type branches, U-type and UG-type jail. Classifying a line later just means comparing its memory against the strings. And in main, I open input text with browse, open Cisco, and save the file descriptor in SO. If opening fails, FD will be negative and I jump straight to exist program. And readline resets the buffer pointer and character count. Then read char reads 1 byte at a time using Cisco hw3. If a byte comes in, I check it. A new line means the line is done. A carriage return gets skipped, and otherwise the character is kept and the count goes up. If I hit end a file with no bytes read but characters already buffered, I still process that last line. If there's nothing buffered at all, I'm truly done. And once a line ends, I know terminate the buffer, skip it entirely if it's blank, then echo the row line back out before classifying it. That just makes the output easier to read line by line. Next, next I uh,
Next,
next I call get mnemonic to pull just the instruction name out of the line. That subroutine is defined later in the file near the bottom, so I'll come back to it. I'll also reset S3 and S4 here. S3 will hold the type code once classified. S4 just flags whether anything match. Okay.
okay, so now the classification itself. For R type, I compare the token against each R type and mnemonic in the turn using subroutine, also defined later, which returns 0 into a 0 on a match. The moment one matches, I jump to set R store type code 1 and go print the results. If nothing matches, I fall through to try iLoad and repeat exact the same pattern for I type load. Then I type order of S type, SB type, U type, and finally is UJ type here. It's the same comparison logic copy for every group, which keeps each format isolated and easy to debug. Um, okay, so this part. One thing worth pointing out further down the I type order chain, your get its own type code 8 since it's technically a UJ style jump even though it's written like a I type. And things like fence, score, and the RD cycle family get type code 9 since they either have no operand or no immediate worth printing. If the mnemonic doesn't match anything in any group, I fall through all the way to a no, print a no format, and stop processing the file entirely. Uh, print result. Okay, this part is one big chain of the comparison against S3 dot R type. Just print its label. No immediate I type load and S type both are their immediate inside parentheses like LWA0 for S0. So both co extract IMM parent. I type auto and you type the immediate at the last operand. So both co extract last IMM. SB type and UJ type your print a label instead of a number via extract label and your J despite being type 8 also put it immediate from inside parent list. All, all of these helper subroutines are defined later in the file. After printing, I will branch jump back to the read line for the next line. Okay, so once the file exported, done file, close the file descriptor with a cycle 58 and exit program and the program with a system code 10. Now scrolling down the subroutine get mnemonic, which main call way back near the top. Skip leading space or tab, then copies the character into the token buffer until it hits the space, tab, comma, or the end of the string. That how isolate just That's how I isolate just add or big from the rest of the line. Mm, strcmp use what this part? Oh, use everywhere in the classification chains. Just work both string byte by byte. If it ever find a mismatch, it return to reference in a zero. If it reach both new terminator at once, it return zero match. The next three subroutine all find a specific spot in the line and hand off the paste int for print directly. Extract IMM parent skip past the mnemonic and first operand to grab the number inside the parent list. Extract last IMM find the last common step for instructor where the immediate come last. Extract extract label does the same scan but print the text as a label rather than pressing it as a number. And here finally at the very bottom of the file, pass int does actually number building. Actual number building. Check for the leading minus sign, then read the digit one at a time, multiplying the running total by 10 and adding each new digit. Building the number the way you do it by hand, stopping at the first non-digit character that wrap the whole program. Uh, Thanks for listening.